I welcome you all for my mathematics session. I am continuing with Fourier transforms, but sine transform, and I have taught you Fourier transform, and a Fourier transform is given by, if f of x is a function, then the Fourier transform of this is given by f of x is equal to 1 by 2 pi integral of minus infinity to plus infinity f of x e to the power of isx dx. This is what I taught you as the Fourier transform of a function f of x, and that it is denoted by f of s. And we can go for this inverse Fourier transform, in which case this will be f of s and it is e to the power of minus isx. Now the Fourier sine transform, see, Fourier, I'll start doing the problem itself. The Fourier sine transform of f of x is given by, see, S means it stands for sine, fs of x is equal to square root of 2 by pi 0 to infinity f of x sine sx into dx, and fc of f of x is given by, it is 0 to infinity f of x into cos sx into x. So these are the sine Fourier transform and cos Fourier transform. Fourier sine transform, Fourier cos transform. Now we have to get the Fourier sine transform of the function 1 by x into a squared plus x squared. I will start doing the problem and I will explain each and every step very carefully. Watch how I do this problem, and this is also a very important problem, and often this is being asked in university examination. So let me start doing the problem. See, I'll rub off all this. So this is what we have. So I'll write that. See, given f of x is equal to a squared plus x squared, to find fs of f of x, where fs of x given by 2 by pi 0 to infinity f of x into sine sx into dx. Now that is to find fs of 1 by x into, I hope that you are able to understand what I write on the board. So you simply do this. So it is 0 to infinity, then it is 1 by x into a squared plus s squared to sine sx into dx. So now I see, this is what I should find. I should find the value of this. Can you understand? That means this is the Fourier sine transform of this. I am going to find the value of this. Now let me find this. See this is not straight away, we cannot do. We have to, it requires a lot of working. So I will go step by step. See, let I be equal to, this one you take, square root of pi into 0 to infinity 1 by x into a squared plus x squared sine sx into dx. Now I'll write, because of I require space, I write here, see, or I'll write here itself. Now di by ds. See, di by ds means you are going to differentiate this, and know that if you, this I is equal to something, if you evaluate this integral, it will be a function of s. So I'm going to differentiate this I with respect to s. When I do that with respect to x, now you see that here this sin sx, it also involves x. So I must go for partial derivative of this, and there is no s involved here. So this is nothing but 2 by pi square root of this 0 to infinity 1 by x into a squared plus a squared dou by dou s of sine sx into dx. This is partially, we derive it with partially with respect to s, because this is a function of s and x, and therefore what is that you will get here? So this is sine sx is nothing but what? It is 2 by pi into 0 to infinity 1 by x into a squared plus a squared into s into cos sx into dx. See, the derivative of this, partial derivative of sin sx with respect to s is cos sx into x, because you are going to differentiate with respect to this one, therefore this is x. Now, so this is what you get. Now what you go for the second derivative, d squared I by ds squared. Go for the second derivative. You will understand why I do that. You will understand, if I do that, you will understand why that has been done. Okay. Now what is that you get here now? So d squared I by ds squared is equal to, differentiate this again with respect to yes. So what is that you will get here? 2 by pi, it is 0 to infinity, it is minus x squared sine sx divided by x into a squared plus x squared into dx. So this is what you get. Do not cancel or do anything, because you will not be able to find this. I am going to approach in a different way in order to get the result. So this is what you get. Now what is that you get here? So this is equal to, minus 2 by pi. Within this I can write this as 0 to infinity, it is x squared plus a squared minus a squared, yes, divided by, it is x into a squared plus x squared into sine sx into dx. So what I do here is I pull out this minus sign outside. So 2 by pi, inside that integral you have got this x squared, I add x squared plus a squared and subtract a squared. So this is what I get here. So this is what is that you get here? So this is equal to minus 2 by pi it is, see, this is integral of this. You can split it into 2, so I will write, just you try to understand what I do here. So this is equal to sine sx by x into dx minus a squared, see, minus integral of 0 to infinity a squared by x into ax squared plus a squared sine sx into dx. So I split it into 2 integrals. So this is equal to, what is that you get here? Take this minus sign inside. So this is what you get. So this becomes, this is into dx minus 0 to infinity. This is what you get. Now I will write something here, and this has been proved. I will write here something. You will understand why I write that. Square root of pi. Okay, minus yes, this is equal to. So this I have proved. This result I have proved. So I am writing this. Now can you understand what is that I have done here? So ultimately I am getting this. See, this one d squared, I am getting it as d squared I by ds squared. So I get this d squared I by ds squared as square root of 2 by pi into a squared I minus pi by 2. So this is what I get. Now let me start doing, see, I will continue doing this problem now. So it's, what is that you get now? So let me continue with this. So that is d squared I is equal to, this is what you see, you take that hand side, what is that you will get? 2 by pi into a squared I minus, if we take this, what is that you will get? Pi by 2 square root of this. So this is, so you get this one, you see, I'll write it in such a way that this is, I'll put it in this form, that is, I will write this step, I'll write this step as, see, I will take this d squared I is equal to integral of infinity minus take this inside. So what is that you will get here? This is what I get. So this is equal to, so this will be equal to, so this is equal to this one, you know, this is your I. See? It is 2 by pi into integral of 0 to infinity sine x sx divided by x into dx. Yes. Now you see that this one, you know, this integral is your I. So this is what you get as, see, this is your I. So you get this to be your I squared I minus 2 by pi square root of that into pi by 2, since integral of 0 to infinity sine sx divided by x dx is equal to this. This is I have proved. You go to refer my earlier classes on Fourier transforms, you will find that this is being proved. Okay. Now, what is that you get now? So, this one, you know. So, this is a squared I minus this is pi by 2. This implies d squared I minus a squared I is equal to minus pi by 2. So this implies d squared minus a squared is equal to minus pi by 2. So this is a differential equation of second order. Here I. So this is a differential equation of second order, and therefore auxiliary equation. What is that auxiliary equation? Auxiliary equation is m squared minus a squared. This implies m plus a into m minus a is equal to 0, m is equal to a, m is equal to minus a. Therefore, see, therefore complementary function is equal to, what is that? C1 into e to the power of a. See, this is your d squared I d. See, what is your d? d is d by ds. So you see that that is you're differentiating with respect to s. That means what? This I depends on yes. The I depends on yes. So this is C1 into a to the power of s plus C2 into a to the power of minus. This is your complementary function. And what is your particular integral? Particular integral will be equal to, it is, see, on the right hand side you have got here minus pi by 2 divided by d squared minus a squared. So this can be written as e to the power of 0 s into, what is that? You will have it as what? So it is e to the power 0 s into minus pi by 2 divided by d squared minus a squared. So what is the integration of this? So this is equal to square root of pi by 2. It is. This is pi by 2. So if you were d in the place of d you put 0, what is that you will get here? So a square you will get minus a square. So this is equal to 1 by a square into pi by 2. So this is what you will get. So what is your I? Now you have solved this differential equation. What is this differential equation? This is your differential equation. D squared minus a squared I of I is equal to minus pi by 2. I have solved. See, the auxiliary equation is this. I am able to get the complementary function. I am able to get the particular integral as this. Therefore, I will write it here because I want space. Therefore, I is equal to C1 into a to the power of s plus C2 e to the power of minus as plus, see what is that you have got here? 1 by a squared into square root of pi. So this is your I. So I have found. Now let us find the values of C1 and C2. So this is what I am going to do. So what is that I have done here? I have given the function, I differentiated it and twice, and thereby I am able to get a differential equation of the second order, and I have solved it. You know how to, this is a very simple differential equation of second order. I have got this complementary function, I have got the particular integral. Now I have got this is what I want. This is my I. The value of I has been got. But there you have got C1 and C2 whose value has to be determined. Are you able to understand? Now I will find. See, I is equal to, I have got this I. What is my I? What is my I? My I is 2 by pi square root of that 0 to infinity. It is sine sx divided by x into a squared plus x squared into dx. Now, see, when s is equal to 0, so now you substitute n. See, because I want here, I have to get the value of C1 and C2 by applying some initial conditions. What I do here is, when s is equal to 0, your I is equal to 0. See, I is equal to 0. When s value is 0, you see that because when you put s is equal to 0, your I is equal to, because sine 0 is 0, the whole integral becomes 0. So what is that you will do now here? So you see that when you put, so I will rub off this. See, I will rub off this. So I will write here. So when s is equal to 0, so what is that you will put? Now we have got here I is equal to C1 into e to the power of as plus C2 into e to the power of minus as plus 1 by a squared pi by root of this. So when s is equal to 0, implies I is equal to 0. Therefore 0 is equal to C1 plus C2 plus 1 by a square pi by 2. So you see that e to the power of 0 is 1. So this implies C1 plus C2 is equal to minus 1 by a square pi by square root of pi by 2. So you see that I am able to get one equation. I am able to get one equation because for getting the value of C1 and C2, I must have two equations. I am able to get one equation as what? C1 plus C2 is equal to minus 1 by a squared into square root of pi by 2. Now, you take this di by ds. What is your di by ds? Di by ds is equal to, see, when you put s is equal to 0 here, when you put s is equal to 0, now let me put here, see, this is, see, I will write here, so this is equation number 1. Now I will do the, see, let me get another equation. That means what? I must get another equation in C1 and C2 and then solve for C1 and C2. Now let me try to get the second equation. Now you take this, I will call this, you call this as your 1. Call this as your 1. Now see, when s is equal to 0, when you put s is equal to 0, what's your di by ds? See, di by ds will be equal to 2 by pi square root of this 0 to infinity. When you put s is equal to 0, cos 0 is 1. X and x will go off. Can you understand? So this is x into cos 0 is 1 divided by x into a squared plus x squared into dx. So this x and x will go off. This is nothing but what? Your this one. So this is equal to what? This is what you get as square root of 2 by pi into 0 to infinity of dx by what? A squared plus x squared. But this is nothing but what? The integral of this is 1 by a into tan minus 1 of x by a. So this is nothing but 2 by pi into 1 by a into tan minus 1 of x by a, and this must be raised to 0 to infinity. So this is equal to square root of 2 by pi into, you see that when you put x is equal to infinity, tan minus 1 of infinity will be pi by 2. When you put x is equal to 0, tan 0 is 1. So you see that tan minus 1 of 0 is 0. See, but when you put x is equal to infinity, tan minus 1, tan pi by 2 is infinity. Therefore, pi by 2 is equal to tan minus 1 of infinity. So what is that you will get? So I will write one step here. This is nothing but tan minus 1 of infinity minus tan minus 1 of 0. So this is what you will get. But this is equal to square root of 2 by pi into 1 by a into tan minus 1 of infinity is pi by 2, and this is 0. Can you understand? So you say what is that you will get here? So this will be equal to 2 by pi square root of this into 1 by a into pi by 2. So this pi and this pi will go off, giving you what? It is square root of pi into square root of 2 into 1 by a. So what is that you get? So when s is equal to 0, then di by ds is equal to what? It is equal to 1 by a into pi by 2 of this. Okay, so when s is equal to 0, you are getting this. Now let me start doing this. So what is that you get here now? So now take this. I is equal to what? I is equal to C1 into e to the power of ax plus C2 into e to the power of minus as plus 1 by a squared into this. Now what is your di by ds? It is equal to C1 into a to the power of as minus C2 into a e to the power of minus as plus 0. Because this is a constant and therefore with respect to s it is 0. Now when s is equal to 0, see when s is equal to 0, I have written here, see when s is equal to 0, your di by ds is equal to 1 by root 2. So I will call this as 2, by 2. By 2, what is this? 1 by a into pi by 2 of this. So when you put here, see what is that? When you put s is equal to 0, this is c1a minus c2a. So this one, when you put s is equal to 0, di by ds is equal to 1 by a into square root of pi by 2. So when you put s is equal to 0, when s is equal to 0, by 2 I have written. When s is equal to 0, by 2 we get 1 by a is equal to 1, root 2 is equal to this much. Therefore, what is that you get here? So this implies c1 minus c2 is equal to 1 by a squared square root of pi by 2. So call this as your 3. Now what is that you will put here now? So you have already get c1 plus c2. Now what is that you get now here? c1 minus c2 is equal to 1 by a squared, see 1 by a squared into pi by 2. This is your 3. Now you see that I am able to get two equations involving c1 and c2. I can solve this, substitute here, your problem is over. Now let me start doing this. See what is that you will get here now? So what is that you will get here? So you have got this c1 plus c. Even I can just rub off of this so that I want space here. So let me solve this. So what is that you do? Now you see that you add. See when you add, see 1 plus 3. When you add, this c plus 2 and minus 2 will go off. These two will vanish because this is minus, this is plus. So this implies 2c1 is equal to 0, which is equal to c1 is equal to 0. When c1 is equal to 0, what is that you get here? So when c1 is equal to 0, so naturally c2 will be equal to what? c2 is equal to minus 1 by a squared into pi by 2. And c1 is equal to 0. So is it very simple? We have got. So solving these two equations, I am able to get what? When you add, these two will go off. These minus and plus, these two will go off. 2c1 is equal to 0, so c1 is equal to 0. So when you substitute c1 is equal to 0, c2 is equal to so much. So we are able to get the result. Therefore, we will call this as our A. We will call this our A. Substituting in A, we get, what is that you get here? So I is equal to, what is that? C1. What is your C1? C1 is 0. Plus, what is your C2? Minus 1 by a squared into pi by 2 of this C2 into e to the power of minus as plus 1 by a square root of this. So this is what you get here. So this I will be equal to, take this 1 by a square root of pi by 2 into within brackets e to the power of minus as. That is, so what is that you get final answer? So I am able to get this I. So I am able to get this I. See? This I. But I is equal to what? What was your I? But I is equal to what? 2 by pi. square root of this 0 to infinity sine sx divided by x into a squared plus x squared into dx. Therefore 2 by pi square root of this into 0 to infinity, it is sine sx divided by x into a squared plus x squared. This is equal to what? 1 by a squared pi by 2 square root of this 1 minus a to the power of as. So this is your answer. Now, so finally, how should you give the answer now? So we have found. So this is our answer. So I'll write the final step. So what is that you get? Therefore f of fs 1 by x of a squared plus x squared is equal to 1 by a squared pi by 2 square root of this 1 minus e to the power of minus. So this is a different type of problem, and it is an important problem, but here it requires the idea of how to approach. It requires a lot of idea how to approach. You have to differentiate once, twice, and then solve a differential equation, and then apply initial conditions as s is equal to 0 in the case of I, s is equal to 0 in the case of the first derivative of I with respect to s. Substitute, you will get a relation of this type I. You have to get the value of C1 and C2 by using s is equal to 0 in I and s is equal to 0 in di by ds, and thereby you will be able to get the value of C1 and C2. Once you get the value of C1 and C2, you substitute and you will get the answer. This is how this is done. This is an important problem. Take care of this. We will do more problems in the coming days. This is my lecture 4. Fourier transform, lecture 4. This is. So I'll meet you in the next class. Thank you.